Hello guys, in this video we are going to discuss the solution of the problem nearly sorted. So let us look at the problem statement. The problem statement says given an array ARR where each element is at most k away from its target position, you need to sort the array optimally, and we are not supposed to use the standard sort function. So for instance, if this is the array which is given to us and value of k is equals to 3, then after sorting the array will look something like this, and this is how we need to arrange the elements of the array. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is to use heap. What we are going to do is we are going to initially push k plus 1 element onto the heap, and then we are going to heapify it, and we are going to arrange this in the form of minimum heap. And once we are done from this step, all we have to do is pop an element from the heap and then push an element onto the heap, and this pop element which we will get will be in sorted order, and in this way we will be able to sort the elements of the array. So let us take an example in order to understand this. So let us say this is the array which is given to us and the value of k is equals to 3. So the first thing which we are going to do is we are going to push k plus 1 element onto the heap. So these elements will be pushed onto a heap. So let us arrange these elements in min heap format. So the heap will look something like this. And then once we have pushed k plus 1 element onto the heap, the next step is just to pop an element from the heap and push an element to the heap. So let us do that. So let us pop the minimum element from the heap. So this is the minimum element and this got popped. So now the heap looks something like this. And then let us push an element onto the heap. So the element which needs to be pushed is 8. So 8 will come over here. And so far we have just popped one element, which is 2. Now let us again perform the pop and push operation. So the next element which will be popped is 3. So let us put 3 over here. And then after that the heap will look something like this. And then let us push the next element onto the heap. So the next element is 10 and 10 will come over here. Again let us extract the minimum element from the heap. So 5 will come over here and the heap will look something like this. And the next element is 9. So 9 will come at this position. Again let us pop the minimum element. So 6 is the minimum element. So 6 will come over here and the heap will look something like this. Now there are no elements to be pushed onto the heap. So we are going to just perform pop operation while the heap is not empty. So let us pop an element from the heap. So 8 will be popped from the heap. 8 will come over here and the heap will look something like this. Again let's pop the minimum element from the heap. So 9 will come over here and heap will be just one element, which is 10, and then eventually this 10 will be popped and it will be placed over here. And in this way, as you can see, the elements got sorted, and this is exactly what we are going to do. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to sort a nearly sorted array. An array and k is given to us. So for this, let's take a priority queue and let's take I equals to 0. And the first thing which we are going to do is we are going to push k plus 1 element onto the heap. So let us do that while I is less than or equals to k, and all we have to do is pq.append arr I, and then let us update our I by 1. And after pushing k plus 1 element onto the heap, now let us perform the heapify operation so that the array gets converted into minimum heap. So for that I'm going to use heapq. This is a standard library, and then heapify. After that, let's take j equals to 0, and then let us iterate on pq while pq is not empty. So len of pq, and over here all we have to do is we first have to pop an element from the heap. So for that, heap q dot heap pop pq, and this pop element needs to be placed at the jth position in arr. So arr of j is equals to element, and then let's update j by 1. And once we have done that, let us push an element onto the heap. So for that, if I is less than len of array, and folks, please note this I is the same I which we are using over here. So if I is less than len of array, which means there exists an element in the array, then let us simply push this element onto our heap. So for that, heap q dot heap push pq and arr I, and then let us update our I by 1. So I plus equals to 1, and in this way we have sorted the array. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So for that we took a priority queue I equals to 0, and then we have pushed k plus 1 element onto our priority queue, and then we have heapify it so that it becomes a minimum heap. Then we are iterating on priority queue while priority queue is not empty. The first thing which we are doing is popping an element from the heap, and then we are placing that element at the jth position, and then we are increasing j by 1. And if there exists an element in the array, then we are pushing that element onto the priority queue. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. We have a priority queue over here, I equals to 0, and then we are pushing k plus 1 element onto the priority queue. Then we are iterating while priority queue is not empty. We are popping an element from the priority queue, placing it at the jth position in arr, and if there exists an element in array, then we are pushing that element onto the priority queue. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.